This video is part of my software engineering series, 3 common problems and 3 solutions. In this part you will see the third problem, depending on libraries. And solution, hide them behind an interface. I will create this Excel sheet and a Python script to load and show the data. For this I use a library called OpenPyExcel. Then I will change the code to work with another library called PyLiteXcel. You will see that this is not a trivial task and how abstracting the library behind an interface will drastically improve the situation. Here is the project with the Excel sheet. I created a virtual environment and will install both Excel libraries and PyLiteXcel. I create a main script to load the data with the first library. I call the function and execute the code. And that works. Although the code is still small, there are problems with it. The showSalaries function mixes the responsibilities of loading data and calculating the increased salary. Proprietary library data types like worksheet cells have sneaked into our code. I know in this example it looks harmless, but once the loading functionality or business rules get more complex, the risk of breaking things will grow. Let me show you what needs to happen to use the second library. I import PyLiteXcel. I'll comment out the old code and see what needs to be done to load from it. In fact, I had to change all code in the function. Let me test if it still works. Yes, it does. Pretty much all the code in showSalaries needed to be changed because the second library has a different API. Applying these changes require you to test if the percentage calculation still works correctly. But how? You can only do it manually because a unit test cannot test this code without access to an Excel sheet. This is coupled code, where a part of the code is not even under our control. The goal of this tutorial is to separate our code from the library code. For this I will use an interface. But here comes the question. What should it describe? Notice in the code that OpenPyExcel needed to access cells with the value attribute, and PyLiteXcel could do it directly. OpenPyExcel could iterate the worksheet, and PyLiteXcel iterated the worksheet by accessing the row attribute. Their interfaces are different and contain proprietary data types. The goal of this exercise is that all data types in our code are plain Python data types. All proprietary data types need to stay in the library. So we need conversion. I'm going to change the code in 2 steps. I create the interface and the conversion. If you are watching this video, I guess that you like software engineering puzzles just like I do. But what I never got is why some books need 500 pages to explain these down-to-earth concepts. So I did something different. I created an ebook where I explain 3 common problems with solutions. And instead of having to read for 2 days, you can now read it in 5 minutes. But it gets better. You don't have to discuss with Bert anymore. You see, Bert hates patterns and principles. And instead of wasting your time convincing him, you can now just send him a copy of the ebook and proceed with more important things. A link to the ebook is in the description. And now I will implement the changes in the code. Notice that the interface has no dependencies on library code. The load method returns a list of tuples with strings and floats. All these are Python standard library data types. Now I create a module that has the dependency on the libraries. Then I create a class that has a single responsibility: load data by using the OpenPyXL library. At this point in the method, all data is in a proprietary form. I convert it and return it. And I create one for the other library. And again, I convert the proprietary data to Python standard data types. This module now encapsulates all things that have to do with Excel libraries. Classes OpenPyXL and PyLiteXL both implement method load employees with the same signature as in the interface. As you have seen in the previous video from this series, this makes both classes structural subtypes of protocol class Excel. Notice that both classes have very different implementations, but both return the same data type: a list of tuples where each tuple contains a string and float. Proprietary Excel information is now completely hidden behind an interface with Python standard library data types. But watch out! How do we hook it all up? It is very important that the showSalaries function does not create an instance of the Excel classes. This would violate the single responsibility principle and couple the function to concrete classes. One of the consequences would be that the function cannot be moved to another module without the dependencies on Excel classes. So the function will not instantiate the class. Instead, it receives an instance with dependency injection. Let me show you. Instead of the sheet information, the function will receive an object of type Excel. I import the interface and Excel classes. And now I create an Excel instance and pass it when I call the function. And now I can remove all this proprietary code and replace it with the load employees method. And that should work. And it does. Working with a different Excel library is now easy. I create a different instance and run the code again. Very nice. Function showSalaries is decoupled from concrete Excel libraries. Now you will even benefit more from decoupling once you move the salaries function to its own module and start adding more methods to the interface. And if you want to see how that works, click on this video right now. There we will make the example a bit more interesting while keeping all functionality hidden behind the interface.